Hey guys, welcome back to another math lesson with Miss Barnes. That's me. Today we're looking at y equals mx plus b, otherwise known as the slope-intercept form. And that's exactly how it's written. The slope and then the y-intercept. Now let's talk about what those pieces mean. M is our variable that stands for slope. Slope measures the steepness of a line. Measures the steepness of a line. So that's like this. Like which way is it going? How far is it dropping? Is it dropping really steep? Is it not dropping? Does it lean to the left? So we calculate slope by looking at how much the x's and y's are changing. You may have heard it called the rise over run. I know that that's how I learned it. The rise is the x changing. I'm sorry, rise is y changing because the y goes up and down. So the rise is the y change. The run is the x change. And we can write that as delta y, the triangle, over delta x. Now, delta y means the change. So that's change in y over the change in x. And change, when you calculate the change, you subtract. So we're going to be looking at how much one changes in comparison to the other. B in this situation, no, in this equation, that's what I meant to say. B in this equation is the y-intercept. And that is exactly what it is. Where this line would cross the y-axis is the y-intercept. Where it crosses the y-axis. Let's scooch it over. Where it crosses the y-axis. And when it hits that line, so if we sketched a little graph, this is the y-axis. This is the x-axis. If I were to draw a line across this coordinate plane, there's a line. That point right there, that is the y-intercept right there. So this dot right here, that is the y-intercept because that is where it crosses the y-axis. Now, what is the x value for this coordinate? If we wrote this as a coordinate x comma y, let's say y is 2. What is x? X is 0. So we can also say that the y-intercept when x equals 0. So if you know when x is 0, however much y is, that is your intercept. Now, let's go back to slope real quick. There's this trick to remembering the slope rules. I call him slope dude, slope guy, whatever. If the line is rising from left to right, it's a positive slope. If the line is falling from left to right, that's a negative slope. And if you're not sure, you can take your pen and we go from left to right. So that's going up, positive. If I go over that line, it's going down, negative. If it's not going at all, so like slope measures the steepness of a line. So if I had a marble and I was going to put it on this line, it would roll. If I put it on this line, it would roll. If I put a marble on this line, like if I put a marble on the wall, could it stay on the wall at all? No, if that wall is perfectly up and down, it would not roll at all. It would just fall. So that's called an undefined slope. Undefined. And then if you put a marble on a perfectly level surface, perfectly level, would it roll? No, it would have zero movement. So there's my slope guy. He helps me remember what slopes are. So if it's going up from left to right, it's positive. If it's going down from left to right, that's negative. Perfectly vertical is undefined, and perfectly horizontal is 0. All right, now let's do the math parts. If I gave you a table, where I had my x and y values, so x and y values. X is always the top value in a table. And I told you that x was 2, 4, 5, 6. Sure. And when x is 2, y is 8. When x is 4, y is 14. When x is 5, y is 17. When x is 6, y is 20. Now, I know a lot of times when we deal with these kinds of tables, when we deal with these situations, the instinct when we see 2 to 8 is say, oh, times 4. But 4 times 4 is 16. And 5 times 4 is 20. 6 times 4 would be 24. So this is not a times 4 relationship. This is not like constant rate of change. This is not like when we had unit rates and we were constantly just multiply, multiply, multiply. Now we have to come into an idea that this is going to be 2 steps. I'm going to have to multiply and add something. And to figure that out, we calculate the slope. So step 1, I'm going to pick 2 coordinates. Pick 2 coordinates. Any 2 coordinates will work. I'm going to pick the first and the last one because that's what my students did last year. So we're going to pick 2 and 8 and 6 and 20. Okay, now my goal here is to write an equation in the form y equals mx plus b. So what I'm going to do first is find the slope. I'm going to calculate the slope. So now that I've picked 2 coordinates, my slope formula, if I scroll up here, my slope is change in y over change in x. So if I look at my y's, how much do the y's change? So step 2, how much did y change? So from 8 to 20, how much did it change from 8 to 20? 12, sorry. 20 minus 8 is 12. So that is my delta y, or change in y. Now, how much did x change from 2 to 6? 4. So how much did x change from 6 minus 2? That was 4. So that's my delta x. So then I take those 2 things and I write them as a fraction. So step 4, I'm going to put my delta y over my delta x. How much was delta y? 12. How much was delta x? 4. What is 12 divided by 4? It's 3. So this is calculating my m or my slope. So this is m. Or that's how much one thing would be. This is also, it's the same idea as k. It's the same idea as the unit rate. This is what I'm multiplying by. This is what I'm going to multiply by. Now, to find the b, to find where it crosses the x-axis or the y-axis, the easiest thing to do is probably to come back up to the table and see if you can figure out how much y would be if x was 0. Because remember we said up here that when it crosses this axis, that's how much the y-intercept is, and that's when x is 0. So if I come down here, when x is 0, so if I look at this table, if I analyze this table, I can see that this went up 2 here. So that was plus 2. And this went up 6. Well, this one went up 1. So this went up 3. This went up 1. And this went up 3. So every time the x changes one thing, the y changes 3 things. And that's where my slope came in. So if this goes up 2, this went up 6. So to get to 0, I would minus 2. So how much would I minus from 8? If the change is 2, what's the change here? 6. So if I go backwards 6, how much would y be? 2. So if this is up 2, up 6, up 2, up 6, up 1, up 3, because that's half. So that pattern between the change in the x and the change in the y's has to be proportional. 6 divided by 2 is 3. 3 divided by 1 is 3. Negative 6 divided by negative 2 is 3. So that's where I get my slope of 3. And now I know that my y-intercept is 2. So when I write my equation, y equals m of 3 x plus b is 2. So this is going to be b. Now, what that equation does and how I can check it, and we're getting into a part of math that's kind of cool because you can always check your work. And it's work that you can check because you created it and it works. So if I take an x from the table, let's test 4 and 14. If I put x of 4 into this equation I just wrote, what does that equal? 3 times 4 plus 2. It equals 14. So when x is 4, is y 14? Yeah, it works. So I know that whatever my x value is, I triple it and add the 2. So 6 times 3 plus 2 is 20. 5 times 3 plus 2 is 17. 2 times 3 plus 2 is 8. So we've written the rule that I know whatever I have, x value, if I triple it and then add 2, that tells me the y. So if I'm writing my equation, the first thing I do is find the slope by following this. If there's not a table, create a table. And then once I know the slope by following those steps, I go back up to the table. I guess we can add a step 5 and calculate the y-intercept by finding when x is 0, how much y is. You can also come over to the equation and plug in y of 0. I'm sorry, x of 0. You could plug in x is 0. So if I knew 3 times 0 plus 2, because we know that x has to be 0. Let me scooch. When x is 0, that's the y-intercept. So 3 times 0 would be 0 plus 2 would be 2. So the y-intercept when x equals 0, this is the other way you can figure that out if you don't look at the table. So pick a way that's comfortable for you. Use the table. Do work backwards with the equation. Ask questions on this one, because if it's something that you just aren't getting, ask questions. This is where I fell apart in 7th grade because I didn't understand it and I just needed somebody to explain it a different way. So if you're struggling, reach out, find other YouTube videos that might explain it differently. Ask a different math teacher, ask me. This isn't the only way that I can explain this, but this is the way that reaches the most people the first time, the best way. So if you're not getting it, reach out on Zoom and I would love to walk you through this a different way. So good luck. Don't give up. You'll get this.